Good morning, dear student. Today we'll discuss about the topic belt, rope, and chain drive. Uh, why we are discussing this topic? Because we know in these days automobiles, belt, rope, and chain is the most important part that transfer motion from one shaft to another shaft. When we start the transfer motion from one shaft to another shaft, it is understand that motion is transferred from one shaft to another shaft. In every shaft, a wheel is added so that it may transfer. Now understand when two shaft is there is a gap between two shaft. Okay, and we try to start the motion given one shaft. Now, what this shaft will be do? This shaft give the moment to another shaft. How it happened? We connect. Any problem? Okay, we connect these two shaft with a drive that is chain drive. Okay, it means there is a crank which is attached with the chain. This is the first method. Second method is that I may connect these two shaft with the help of belt drive. With the help of belt drive. Again, one shaft is driver shaft, another shaft is driven shaft. It means driver shaft provide motion to driven shaft with the help of belt. Now, third method. When two shafts are here, I may connect these two shafts with the help of gears. With the help of gear. Now, one questions come in your mind that if our motor will fulfill with the help of chain, why we need belt? Or if it is with the help of belt, why we need gears? What we are doing? We are transferring motion from driver to driven. But as all of we understand that the most important part is loss of the motion due to the friction. In chain, after some times chain will be get loose. It means it no transfer the desired motion from driver to follower. Like shame, excuse me, sorry. Please keep it with you and put it silent. Now, in same manners, if you use the belt, then the slip occur. It means belt will get loose. Means if we connect these two pulley with the help of belt, or when the belt get loose, it will not transfer desired motion to driver to driven. It means there is a loss of motion, and in case of belt, this loss of motion is known as slip of the belt. So slip of the belt first occur between the driver and the belt, and then it occur between the belt and the driven, and these two lines known as law of slip of the belt. Now move forward. If we attach gears between the shaft, then what happened? It will give very less motion. It means the motion is very less, loss of motion is very less. It means if we provide B1 motion to the driver, same motion will be provided to the driven also with the help of gear. So in automobiles, we generally use high transmission of motion for gears. Okay. You may see it at Google also that how arrangement is possible. You may see here that you may put here like that gear arrangement. gear and puts into here. Look at how this look this simple diagram that how this gears is used. You may see here that थोड़ा zoom कर लेते हैं इसको. You may see here that how the gears transfer motion from one shaft to another shaft, and it's continue from end of the shaft. It means with the help of gears n types of arrangement is possible for the shaft. We may transfer the motion without any loss. Another thing is that most beautiful things of gear that let if two shaft is connected by gears like this, the motion is in opposite directions, and if the three shaft is connected, the motion is in the same direction. It means if there is a odd arrangement between the shaft, there is a odd gears between the two shaft, the motion of first and last will be the same. If there is an even arrangement, even gears between the shaft, the motion of first and last will be the opposite. In Google's, you may also search that how type, what types of gears teeth is there. It is look here that or different types of arrangement is known as different type of things. Means you may put here that like this gear arrangement. You may see here in the automobiles field, or you may like that compound gear arrangement, gear train. So when one gear is connected with another gear and it gives motion, this arrangement is known as gear train. You may put here the image. You may so look. These are known as gear trains. When 2, 3, 4 gear are connected, it is known as simple gear. When on the single shaft, if two gear is there, then it is known as compound gear train. Look here at. Okay, if one gear is completely rotating with another gear, then this type of gears is known as epicyclic gear train. Okay, so come to our slides. Let's see here. If we look that, if we look here that how kind of this chain arrangement is possible. Just hold for a second. Let's go back on previous things at how it's work like notes pad here. Okay, come. Now on the next slide. Now you have the possibility between two shaft is that either it's depend upon its distance or it's depend upon what kind of motion is providing from these two shaft. So for selection of the belt, we must have to focus these points like speed of the driving and driven shaft. Now it is clear what is driving or what is driven. Driving shaft is driver shaft or driven shaft is follower shaft. Then speed of reductions ratio, then positive drive requirements, then shaft layouts, then service conditions. All these points come under this. Now types of belt drive: light belt drive, medium belt drive, and heavy belt drive. Look, these names are self understood that it's put according to the motion of the shaft. Like light drives, it means the speed of belt about 10 meter per second. Got it? When medium drive, it means the speed is about 10 to 22 meter per second. And when the speed is above 22 per meter second, it means it is heavy drive. Ma'am, where is Mr. Manish? Please say them to come here. And now these are the types of belt. It means shape of the belt, that what we are using to drive the motion from one shaft to another shaft. Okay, look here. This is the flat belt drive, this is the B belt drive, and this is the circular belt drive. These are the shape of the belt. In next slide we'll see that how this shape is working. Look here that if one drive is connected with another drive, it means there is a transfer of power from one drive to another drive. It means tension is created here because Look, if a motion is in this directions and we pull anything from here, it means here the tight side tension is tight side here, and if we release the same thing at here, it means this is slack side, means less tension. If it is T1, if it is T2, it means T1 is greater than T2. Now it's clear. Now moving further, we come this is, look here what the arrangement is. Suppose if two drive is like this and you add a motion belt like this, it means motion is same direction, isn't same direction, and you want the motion is in opposite direction. On that case what we will do? Anyone from the class? Okay, good. Means we arrange it as a cross belt drive. Look here. Now here the motion is in opposite direction. Means gear A is moving here, gear B is moving here. Is it clear? Now move forward. Look here that this is another types of belt drives where we may add the belts. Quarterly belt drives, in case of pulley quarter turns is possible, right angle turns is possible. All these are the parts of different kinds of belt drives. Suppose if we need to transfer motion from another directions, we may add the ideal pulley between the arrangement. Here you may look here that this is the ideal pulley. What this pulley is basically doing here at tight side, it provide extra effort to here so that the belts get more tight and transfer of motions from driver to driven. Is it clear? Now here this is the driver, this is the, here what we have done basically, we add two or three idle pulley. What this idle pulley is doing, it's just losses the actual motions and transfer its desired motion. So we are using the ideal pulley. This is the compound belt drive. Look here, in one shaft, when in one shaft two pulley is connected, then it is known as compound belt drive. If one shaft one pulley is connected, this is a simple gear train, and the complete arrangement is known as compound gear train. Look at here, driver is in 1, at 2 there is a driver pulley, at 3 there is a driver pulley, and now 4 is the driven. It means the basic arrangement is like this. The basic arrangement is like this. In this pulley, one pulley is here in this shaft. In this shaft, two pulleys like this, and is this shaft, one pulley is like this, and the belt is connected like this or like this. So in actual view as engineers, we may write it like this, but the arrangement is like this. This type of drive is known as compound belt drive. Okay. Now done. Okay. So move forward. We this is the different types of belt drive, that how it's loose, how it's act. Now this is velocity ratio of belt. Actually, why this topic is taught to you, because you want to understand that this topic is taught to you that because I want that you most have to understand that how this motion is transferred. So motion is directly related with the velocity. Sorry, excuse me. So now you first we understand that how the motion is transferred from one shaft and how much motion is transferred. Look, this shape is like a circle perimeter, and the wheel shape is like this only. So the perimeter of a circle is 2 pi r. It means this is pi d. Is there any confusion? Now one wheel is rotating and times. It means this wheel is rotated pi d into n. As this wheel is the driver wheel, it means it is 1. So we put here n1 and d1. Now this will transfer the motion to another wheel, that is follower. Maybe the shape of the follower is different, like this is small or big, we don't care. But the motion must be the same. Suppose it is d2, diameter is d2. So here the perimeter is pi d2 and it's rotate n2 times. So this is n2 times, or actually the time amount is same, like 1 minute, 2 minutes or 1 hour. The motion will be the same. It means pi d1 n1 equal to pi d2 n2. So here the speed ratio is n2 by n1 equal to d1 by d2. It means the speed of follower upon speed of driver equal to the speed of driver upon the speed of the follower. Sir, done now. Now look forward. There is another calculation of that. Suppose in case of compound arrangement, if more than one wheel is attached. So now you think, if we attach a single shaft on a driver and we add two pulley on it, is it possible to rotate it in different motion? No, it's not possible. So here the speed of this wheel and this wheel will be the same. Look here. It means n2 equal to n3 because both are connected on a single shaft. Okay, so what the total speed will be for driver 1? This is n2 because it is connected by a single belt. n2 by n1, d1 by d2. For driver 3 and 4, it is n4 by n3 equal to d3 by d4. Now we multiply both. So here n2 by n1 equal to n3 by n4. Now look, n2 and n3 both are attached on the same shaft, so speed will be the same. So sorry, it is n3 or n1, but the diameter is different for different wheel. So the basic thing is that n4 by n1 is d1 d3 upon d2 d4. Here what is the d4? What is the n4? N4 is the speed of last driver. N4 is the speed of last driver, or n1 is the speed of the first follower. So speed of last driven upon speed of first follower or first driver equal to product of dia of driver upon product of dia of follower. Look here, d1 is driver, d2 is follower, d3 is driver, d4 is follower. So here d1 into d3 upon d2 into d4. So it is product of diameter of the driver and product of diameter of the driven. ठीक है. सो आज की क्लास को अपन यही खत्म करते हैं, पर आगे मिलेंगे. सर आप पॉज कर दीजिए, स्टॉप कर दीजिए. करवा दिया, सब बंद करो. हाँ तो काफी है भाई.